Hello everyone. So today we're going to take a look at this problem from the 39th International Mathematical Olympiad 1998. This problem states, determine all pairs a and b of positive integers such that ab squared plus b plus 7 divides a squared b plus a plus b. So in order to solve this, I'm going to write first what we know. So we know that a and b are positive integers, and ab squared plus b plus 7 divides a squared b plus a plus b. Now I'm going to use this expression in order to hopefully simplify it in a sense. So I'm going to multiply the right hand side by b, and since this does not change the fact that ab squared plus b plus 7 divides the right hand side because we're just multiplying it by b, ab squared plus b plus 7 still divides a squared b squared plus ab plus b squared. I'm just gonna write here just multiplied by b. Now I'm gonna write this in fraction form because I think it will make my next step a lot clearer. So I'm gonna write it like this. Now what I'm going to do is I'm going to subtract it to a times ab squared plus b plus 7. The reason I'm doing this is because I want some terms to cancel out. So a squared b squared will cancel, and also ab. Now this will equal b squared minus 7a all over ab squared plus b plus 7. Now since this is divisible by ab squared plus b plus 7, and also this one, obviously because there's a factor here, we know that ab squared plus b plus 7 must also divide b squared minus 7a. So this right hand side is obviously much simpler than the one we started with, because now we have two terms. So from this, I'm going to consider three cases for b squared minus 7a. So I'm going to write case number 1, where b squared minus 7a is greater than 0, so it's positive. So since ab squared plus b plus 7 divides b squared minus 7a, it must be less than or equal to b squared minus 7a, because in order for it to be a divisor, it must be less than or equal to the one that it's being divided to. So putting everything to the left hand side, we get ab squared minus b squared plus b plus 7 plus 7a, which is less than or equal to 0. I'm going to factor b squared out. There. Now we know that b plus 7 plus 7a is always positive because, well, a and b are greater than 0. And also, this is non-negative because the lowest value that b squared times the quantity a minus 1 can be is 0. For example, a is 1. But anything else, it's always positive. So a non-negative value plus a positive value is obviously something that's positive. Since left hand side is greater than the right hand side, there is a contradiction, because obviously because of this less than or equal to, it should be negative, but since this is always positive, there's a contradiction. Now, case number 1 clearly does not work. So I'm going to try case number 2, where b squared is equal to 7a. Now, I'm going to let b be equal to 7k, which implies that a is equal to 7k squared. Now from this, I'm going to go back to the original equation here, or expression. So this whole thing, because I'm going to substitute b equals 7k and 7k squared. So we know that ab squared plus b plus 7 divides a squared b plus a plus b. So 7k squared times 7k all squared plus 7k plus 7 must divide 7k squared times 7k plus 7k squared plus 7k. Now I'm gonna simplify. This becomes 7 cubed k to the 4th plus 7k plus 7, which should divide 7 cubed k to the 5th plus 7k squared plus 7k. Now this is obviously true, because this right hand side can be factored by k. So we can see that this and this, so it clearly divides the left, or the right hand side rather. So therefore all pairs a b in the form 7k squared comma 7k is a solution. Now case 2 works, but we have case 3, which is b squared minus 7a. So b squared minus 7a is negative. Now since it's negative, we know that ab squared plus b plus 7 must divide 7a minus b squared. The reason that it divides 7a minus b squared is this is negative. So this is negative and this is positive. And the only way for a positive number to divide a negative number is if it also divides the positive value of this, which is 7a minus b squared. This is achieved by just negating it. So this is negative b squared minus 7a. So this implies that ab squared plus b plus 7 must also be less than or equal to 7a minus b squared. So it's similar to case number 1, and we put everything to the left hand side. So ab squared minus 7a plus b plus 7 plus b squared, which is less than or equal to 0. Now I'm going to factor a here. And it's clear that this right hand side is positive once again. Well, not the right hand side, but this part of the left hand side. And this a times the quantity b squared minus 7, well, this must be negative in order for this whole inequality to hold. Because if it's positive once again, like in case number 1, this left hand side would always be positive and there will be a contradiction. Thus a times the quantity b squared minus 7 must be negative. However, we know that a here is a positive integer. So this implies that b squared minus 7 is greater than 0. So b squared must be less than 7. And since b is a positive integer, there are only 2 values for b here. So it's either b equals 1 or b equals 2. If it's 3, 4, 5, this inequality wouldn't hold. So we're gonna find values of a and b where b equals 1. So I'm gonna go back to this expression. So ab squared plus b plus 7, which divides 7a minus b squared, and substituting b equals 1, we get a plus 8, which divides 7a minus 1. And I'm gonna write this into a fraction once again, so that's much clearer. And this is equal to 7 times the quantity a plus 8 minus 57 all over a plus 8. I'm doing this because I'm trying to simplify to only one term, because this is obviously divisible, but also which means that this 57 is also divisible by a plus 8. So a plus 8 must divide 57. Now 57, we can just do some factorization here. So its factors are 1, 3, 19, and 57, and a can only be -7, -5, 11, and 49. But a is positive, so we don't count for -7 and -5. So therefore, a and b, which is 11, 19, and 49, 57, are also solutions. So these are solutions for when b equals 1 here. Now, there's another case, which is b equals 2, and I'm going back to this one. So ab squared plus a plus b plus 7, right? So it's plus b plus 7 will divide 7a minus b squared. Now this is 4a plus 9, which divides 7a minus 4. I'm doing the same thing basically, which is express it into fractions. I'm gonna take a factor of 4a plus 9 out, and in order for it to be 7a minus 4, I'm gonna multiply it by 7/4 plus something. I'm just gonna call it x first, because I don't know, it's not clear to me what x is. I'm gonna do some algebra here. So 9 times 7/4 plus x must be equal to -4. So x is equal to -4 minus 63 over 4. So it's negative 79 over 4. So this becomes 4a plus 9 7/4 minus 79 over 4 all over 4a plus 9. So this implies that 4a plus 9 must divide -79 over 4, which does not occur. There's no value of a that's a positive integer such that it divides -79 over 4. So therefore, there's no value or pair for a and b here. So therefore, the only solutions are 7k squared, 7k from case 2, 11 comma, what you got, so 11 comma 19, and 49 comma 57. So these are the only solutions. So we're done.